Good morning, everyone. I'm Ria Chetia from Denvi EduGrow AIML Training and Internship Program, which is powered by Something Technology Private Limited. It's a pleasure welcoming to you all. And before we dive into the details, I want to take a moment to thank each of you for being here and choosing to invest your time in this exciting journey. At Something Technology, we believe in innovative technology, empowering education. And our mission is to bridge the gap between what you learn in the classroom and the real world skills that our industry demands. And Denvi EduPro is one of our flagship initiatives to make that happen. So let me give you a small brief about us. It is Something Technology Private Limited, innovating technology, empowering education. It focuses on training, innovation, and digital transformations. It works across edtech software solutions and AI-driven applications, committed to building future-ready skills in students and professionals. It is a flagship project of Something Technology, which is dedicated to skill building in emerging technologies like AI/ML, IoT, cybersecurity, and more. Offers workshops, internships, and projects based on learning programs for colleges and universities. It aims to bridge the gap between academic learning and industry requirements. So, uh, Welcome to the Danvi EduPro AIML Training and Internship Program. This 15 days internship program, powered by Something Technology Private Limited, is designed to equip students with practical AI and ML skills, provide exposure to real-world tools and datasets, encourage hands-on learning through projects and assessment, offer certification for successful completion. So it is a 15 days program which is start from 3rd July and ends in 17 July 2025. The format I'll tell you, but it will you guys can have daily life interactive sessions, assignments, assessments, and projects. Final After completing these sessions, we'll take a final assessment and give you certification. It is full on online mode via Zoom, and also the recording sessions will be available to you. If you missed, you can see that sessions and all. If you guys have any doubt, you can always ask for us. Our trainers will available for you to solve your problems or any doubts you have. So what you will learn in this program, you will learn AI/ML fundamentals, model building, hands-on tools of Python, Jupyter, etc., real-world projects, quizzes, assignments, and final tests. After successful completion, we will give you some certificates. We have some guidelines for you guys. Uh, Assignments and submissions. You need to complete and submit assignments on time. Maintain originality in your submissions. Please use ChatGPT a little less, and the marks will be awarded based on your accuracy and effort. Certification requirements are also there. You have give minimum 75% of attendance in the sessions and submission of all assignments and quizzes and successful completion of the final test and project. So this is more than just a training. It's a launchpad to your AI/ML journey. So we have your first trainer, whose name is Freddy Aman. He is from Arusha Technical College from Tanzania. He is a associate professor there since 2019. He will guide you through AI/ML, uh, AI/ML teaching, and let me hand over to now Freddy Aman. Freddy, are you there?
Here. Good morning. Is it good morning, right? Okay.
Hello.
Can
Sorry.
you hear me? Am I audible?
Yes, sir.
Freddy, your voice is breaking.
Is little. Ria,
Freddy, you are audible.
Okay. My name is, should I go on from here?
Hi, yeah.
Okay. My name is Fred Amon, as introduced, from Arusha Technical College. I'll be starting with the introduction of AI and ML, and then we'll see how it goes. And then we'll be, in this session one, we'll cover a little bit more of theories. But after we break, we'll be coming back with some hands-on where we'll be trying to see exactly what we learn, how we can actually do it in actual sense. So with the introduction, can you please share the introduction remarks so I can also, can I turn off the camera now so I can start sharing?
Yeah, sure, Freddy.
Okay. Mhm. 1 minute. Okay. Can you see the screen now? Hello? Hello.
Yes,
Can you
yes, Freddy, your
see?
screen is already shared.
Okay, so let's start with some introduction of AI, whereby we'll be covering the generality of AI, and then we'll start with some DL, machine learning, just to get the overview of all these things. So the contents that I'll be covering will be including the definition of terms, which are mostly associated when we are talking or when we are speaking about AI. And then we'll have a summary of AI, because AI has been around for a bit quite some time. So we'll see the summary of it and where we are as of 2025. We'll check the fundamentals of machine learning, fundamentals of deep learning, and then we'll cover a little bit of generative. Might not. Oh, we'll cover a little bit of generative AI, whereby it's still about DL, but we'll see how it will be. So starting with AI, artificial intelligence, which is the full form. Okay, 1 minute. These and this. Also, there are two people waiting to view, waiting to enter. Can you please accept them for someone who is also in the group? So artificial intelligence, for short, it's AI. So we are putting it for short. So next time we can go on using AI without telling the full name. So basically AI, what we are it's trying to do, or what do we mean by AI? We basically refer to a simulation of human intelligence in machines that are programmed to think, learn, perform tasks typically requiring human cognition. So that's the basically definition, or basically when we say AI or artificial intelligence, that's what we refer. It's a machine which is either programmed or mechanical, but the only thing is trying to be able to simulate the human intelligence it's trying to mimic the human intelligence. That's it. So this AI system, they design to perceive, but to ensure like human living environment, they are becoming much better, since there are machines which are able to mimic some of the decision that could be made by humans, some of the action which could be made by humans. So that's the basic. So some of the action, it's perceive the environment, reason about data, make decision. Just like when we are perceiving on any data, we'll see once we go on into depth but we'll see how these machine learning or AI require data and reason about data or make decisions when they are given data. A second term is machine learning. In the definition here, it says it's a subset of AI. We'll see a drawing later on. But when we say machine learning is subset of AI that learn from data, the keywords we need to take from this definition is that machine learning, it learns from data and improve performance without explicit programming. So with machine learning, we said it's way trying to mimic the human, but without mimic the human without them having a full intervention of anything that was supposed to be done. But there is a difference between programming or any programming with machine learning. With machine learning, with AI, we see there's supposed to be data. So same applies to machine learning. There's supposed to be explicit data available so that machine learning it can be possible or AI can be possible and deep learning later on it can be possible. So instead of with programming language, it's follow rigid instruction. I think by this time, most of us, we already seen how programming works, and it's basically instruction whereby you're supposed to follow. If you wrote those instructions, the machine will be following those instructions, which when we say rigid, what we mean is like they're unchanged, like they're already predefined so that the machine will be following those instructions. But with machine learning and AI, what we seriously mean is the machine can learn from data and improve performance with explicit programming without having explicit instruction. So this instruction which will follow after we already made the model from machine learning from AI, the instruction, the machine itself will have to judge based on the data it has, will create a decision based on the data that it has. So that's a very good thing to note from the part of machine learning and AI. Same again, we'll be going to deep learning. Again, the definition of that it's a subfield of machine learning. Some other scholars define it as subfield of AI, like deep learning and machine learning, they're in the same level. So this is just still debatable as deep learning and machine learning, how should it be placed? But some sources define deep learning as subfield of machine learning that use artificial neural network, ANN, with multiple layers, deep architecture to complex pattern in data. So basically, it's a little bit more advanced, more than machine learning, but it's also usage of deep learning and machine learning. There it depends on where we'll be using data. For example, deep learning has come much better, has done much better with image recognition. Like if you have a bunch of images, you want to try to recognize them using machine, you have to want to teach the machine how to recognize the image. The deep learning has advanced more into that. But for machine learning, also it has advanced in its own way. For example, in predicting things like weather, predicting air pollution, all that. So most of these, there are parts of AI, and there are quite a little bit, there is a quite difference with programming language as I've introduced. Like they can have instruction which are quite a bit different from the one which we from the rigid instruction in programming language, which are always predefined. So with deep learning, we say it's power many of today's advanced AI. As we can see, we have a lot of AI players, people who are using smartphone. You have smart assistant AI, for example, it's Siri. It's a lot of smartphone has these AI assistants nowadays. So it's mostly powered by deep learning. And then there is image recognition, natural language processing, and autonomous vehicle. Autonomous vehicle, I think you've always seen the vehicle which can be able to drive themselves. The natural language processing, it's AI, but it's how do we say, it's when you don't understand, let's say Hindi, you can use AI to record the voice in real time, and then the AI in background, the model in the background, the deep learning in the background will be translating that language in real time and then giving you the what is being said in any language, either in English, French, or for example, in my country, Tanzania, it will be in Swahili. So go on with the fourth term, which will third, it will be generative AI. For short, is Gen AI. It's also a subset of artificial intelligence focused on creating new content such as text, image, music, even code, rather than just analyzing or classifying existing data. So basically, this one will be generating everything new data based on the data it's already fed to the model. So I think this is the place where the introduction was saying don't use a lot of AI in your assignment. So generative AI is also powered by advanced deep learning models, and it's basically you have to feed data, and then it will be creating new data based on those ANN, artificial neural networks, whereby from those it will be able to generate new data. It's not plagiarizing, it's not copying, it's generating new data. So let's, from this figure, get the overview of AI, artificial intelligence. So with the first one, the huge circle, it shows that AI, it's cover, when we talk about machine learning, deep learning, generative AI, and also there is one more idea I'll introduce after this. All these fall under AI. And then when we speak about machine learning, we'll cover a bit more later. We'll see the fundament of ML, the fundament of DL, and generative AI. So this is all the summary of AI. So there are vast careers based on AI. There is NLP, there's many, there is image classification. We'll see it from there. So I tried to see which could be the types of AI. From the broad overview of this summary of AI, the picture, we can see there have been several advancements for several years, for several decades, until AI, until the current AI advancement, the current deep learning advancement we have now. So before that, the AI, which were already there, we call it narrow or weak AI. Basically, these types are generated, or I've made them based on the specific task, based on the task which the AI is performing. So for example, here I've included Siri and recommendation system, whereby these are only designed for that specific task. I think we all know Siri, it's a personal assistant AI, whereby it will be mostly in iPhones. And then you'll be able to ask for anything, but it will be designated for that specific task. But when we say general AI, this is the hypothetical AI where human-like cognitive abilities across diverse tasks. That's when we refer to AI as general or strong AI. So there are some scholars, I use it in a brackets like it's not full achieved, because there are still some scholars who argue like the current AI we have as of today, 2025, it's not fully covered every aspect of human cognitive abilities. So we still refer to it as strong AI, but we have not reached there. But some scholars you can see online, like they argue like it's already there. But we'll see as we discuss AI and ML, we'll see if we're already there or we are still struggling. There is this concept, which is artificial superintelligence, ASI. This is still in a theoretical AI surpassing human intelligence in all aspects. When we say surpassing human intelligence in all aspects, that means full autonomous. By full autonomous, the current AI requires something it's called prompt. You need to tell it to do something, you need to give it a prompt, and then it will perform the tasks. Like you can tell the AI to summarize the text, and then it will summarize. But itself, it cannot start doing that task without that initial prompt. So this concept, which is only a theoretical concept as of now, the artificial superintelligence, it's supposed to be full autonomous. If you're driving a car, your car, you can just get in a car and then it should start driving without you giving prior instruction to it. So that's the full autonomous we are talking about in the last point. So from that, going to the basics, this is a basic or common AI usage currently. AI has many usage, more than these, the one which are listed in this slide, but there are many usage of AI. So for the basics one, which I'll discuss for today, it involves the visual assistant. We already seen Siri or any visual assistant that is on the phone or on the computer. That just help you on specific tasks on some systems. And then we have recommendation systems. We have chatbots. We have autonomous vehicles. We have image and video analysis. We have language translation, where natural language processing fall in. And then we have fraud detection. And then we have healthcare diagnosis, whereby the CNN will be following in. And then we have smart personalization. This is one of my favorite because I have some smart device whereby if you can turn them on using a smartphone, you can program them to like turn on and turn off anytime. You can turn on using voice. You can turn off using voice, all that. So it's like a smart home can be done also using this AI. There is robotics, whereby they also use AI they use AI in robotics. There is music and arts generation. There is way more concept or way more usage of AI more than this, which is listed here. So from this point, any question about the AI and the introduction of AI before I continue? Am I still audible? Hello?
Yes, sir.
Okay. Any question on AI? Or should I be the one asking question what some other usage of AI apart from the one listed here? What can you think some of other usage of AI apart from these listed here? Okay, let me continue. So we'll start the fundamental of ML, whereby we said ML is machine learning. Since we already covered the definition, we'll start just by going on to see how it works and how everything works under ML. So when we are talking about AI in general, here we are referring to, here we narrowed down to machine learning. We always remember it requires data, and then from those data, this machine will be able to make anything that we're trying to mimic the human based on the data given. So we'll see the limitation, I think, at some point in the lecture. So ML system then by processing large data sets and then optimizing algorithm. So before we go on into machine learning, well, let's just review some of we say the machine learning or AI require data. So we need to review some sort of just few terms that are used in data. When we refer to data, what do we mean? So in machine learning or in AI in general, there'll be terms that are called labeled data, and then there'll be terms that are called unlabeled data. So let's start talking about labeled data. Labeled data, we basically means if it's a picture, that picture has been labeled a cat, a dog, a car, or anything that we want to label, so that we can be able to classify, we can be able to mimic the human based on that labeled data. So for example, let's talk about plant disease. Let's assume we're trying to detect the rice or paddy diseases. We have the leaf of the paddy. Then for labeled data, we'll have one leaf which will be labeled, this is diseased paddy, or this is diseased. Then if we go several levels, we can say there are several diseases under paddy. There could be brown spots, narrow brown spot, rice blast, and all that under under paddy disease or rice diseases. So all those diseases, if we have pictures of them, they will be named with the disease name. So for example, it's brown spot, they will be given brown spot, and then it will be disease. And then for healthy one, they will also be labeled healthy. So basically labeled data, that means these are the data which will be given to the machine learning, but it will be labeled. The machine learning will already learn from the label itself that this data is what. And then we'll see how it works. And then for unlabeled data, this is collection of data, image, or anything that doesn't have labels or annotation. Annotation is just a fancy English word. It just means once you have data, especially images, you need to be able, for example, you went to the field to collect a data set. I'll show one of the data sets here. You went to the field, collect a data set, and then you take several pictures of paddy, of rice leaves, whereby those pictures, they will just be named according to the naming convention of the phone or naming convention of the camera. So annotation, that means you'll need to sit with the farmer, with the farm expert, whereby the farm expert will be telling this is brown spot, this is rice black, this is the healthy rice leaf. So that's basically, then you will be recording, you'll be labeling those data. But unlabeled data, that means those images, they won't have any label or any special annotation which will be showing like this is the image or this is the data that is defined. So I wanted to show just the unlabeled data, and then we'll see how we can go to see the labeled data. So for example, these pictures on the right, which is case 1 and then _191.txt. This is just unlabeled data. Then we'll see how the machine learning learns from unlabeled data, and then how it can be able to do, what do we do with unlabeled data once we start learning exactly how machine learning works. How are we able to train the system or the machine from unlabeled data? From labeled data, let me see how I need to switch to the share. Okay. Anyway, I'll show it later on. I wanted to show this data set from Kaggle, whereby you'll be seeing, I'll need to stop sharing. Okay, let me open it first. Let me stop sharing for some time so I can show it now. Then exit, open this link, and then I'll show you the data set. So we can see the labeled data. Okay. This one is fine. So come back here. Can you see the screen showing the rice plant dataset? This is by Raj Kumar. Raj. And can you see the screen?
Yes, sir.
Okay.
Yes, sir.
So when we speak of labeled dataset for images, this will be something like this. So it will be image, and then we were talking about that annotation. You'll be sitting with the, how do we say? We will be sitting with the expert in the rice, the expert in the paddy planting, and then from seeing each picture, he will be saying this picture is of healthy rice. He'll be commenting based on each and every specific pictures. And then you as the researchers or as the person who you'll be generating or you'll be creating the machine learning, you'll be labeling this, and then later on, these data will be given to the machine learning for learning. So I think up to now, we are able to differentiate between labeled data and then unlabeled data. I think in second session, we'll show how we can also go into training and all that. So let me go back and reshare the, okay. Yeah, so I think up to now, everyone will be able to remember what is labeled data, what is unlabeled data. So from these labeled data and then unlabeled data, I want to discuss a little bit more types of data, which will be structured data and then unstructured data. So we can see a little bit more deep into data, so that when we start going learning how machine learning works, we can be able to realize what type of data we'll be dealing with, or how should we process our data to be able to understood by the machine. So remember, the initial thing we are trying to make is aligned with the definition of AI, ML, and DL. We are all trying to mimic the human. If you're trying to mimic the human, as we have seen the picture, the paddy dataset, rice dataset, it's like we are trying to detect rice diseases. Humans are able to detect rice diseases, who are experts in the rice disease. So they are able to do that. If you'll be trying to teach our machine how to do that, we need the data. So we already seen labeled and unlabeled data. Now let's go see the structured data and then unstructured data. I think it's easy to remember. It's just the opposite of the first thing. So structured data, we're referring to data which is organized, formatted, and predefined manner. That's it. So it can be in form of tables, database, which also is same of tables, or rows and columns in form of CSV or Excel. So types are both tabular and time series data. When we say tabular data, simple, we just data which is in the form of a table. It will be having a column. It will be having a first column, which will be representing the attribute or the feature. So, and then the rows will be representing the actual data. I'll show some of the data set, I think, in second session, while we start with some coding exercise, hands-on. And then the second type of data is structured data. These are time series data. Time series data, it's like the data which we usually say it's continuous. For example, weather data, sensor reading, stock prices. For example, if we talk weather data, I think some of the systems, some of the companies have weather data for the past 50 years. So if you're trying to train your machine learning or deep learning to predict the weather, that means you need to load the weather data for the previous years so you can be able to predict for the next 2 years how the weather will be. So these are structured data. Going to unstructured data is just the opposite of structured data. Data that lack predefined structure or formats such as text, image, audio, and video. The types include text data and image data. Text data include documents. We don't have same formats for documents. Anyone can have different type of documents, articles, social media posts, and all other textual data which don't include any picture, which don't have any picture. And then image data, it will be a dictative image in any image format. Photograph, same as image, and video frames, so that it will be video, but it will be comprising of all the frame inside the video. So after we finish this data and learning a little bit, getting a little bit background of data, I think it's time now we start learning just the introduction of how machine learning works. Remember, the first thing we are trying to mimic. I don't know if other scholars will try to correct me on this, but machine learning, deep learning, AI, we are trying to mimic the human behavior, environment, and all that we already included in the definition. So if you are trying to mimic, we said we require data. And then we have seen different types of data that are required that we can have. And then from those data, we can start training our models or start generating or developing the machine learning and deep learning. So specifically for machine learning, we'll have input data to the model. So the input data can be image, text, number. I think we already seen the definitions of data and all that. So any type of data that we learned just a few minutes ago, that type of data can be used as input data to the machine learning. That's it. So example, you're trying to detect human diseases, cancer, or anything. Let's not talk about cancer. Let's talk about paddy. That's where at least I'm a little bit more good in it. So if let's say we are trying to detect rice diseases, most of them, they will be checking the rice leaf or paddy leaf. They will be checking for symptoms on that paddy leaf to be able to detect what type of disease this is. So for human weight, they'll be checking the rice leaf to see what pattern is it on the rice leaf to be able to say this disease is brown spot, this disease is narrow, and all that. So same way, if we are trying to make a machine learning model which detects paddy diseases, that means our input data will be image, right? If we want to detect the weather, our input data will be string, will be text, will be in form of strings, which will be input to the data, input to the model as input data. And then from this data that we have, we'll need to extract only the relevant pattern. So for example, we have seen that paddy data set. It's just pictures of paddy. So from that pictures of paddy, that picture shows paddy, shows the background of the picture. It has way more features, it has way more pattern, it has way more data than required for, let's say, detecting rice diseases. So from understanding that point, we need to extract the important features that we want so that we can go on to train the model. Let me give a different example on this one. For example, we are talking about weather data. Weather data include a lot of things, include the temperature, include humidity, include several factors, include the air pollution. A lot of factors or a lot of features are there in just weather. So let's talk, if we talk about humidity itself, there are several factors which are impacting, which are causing the humidity. So from the data that we'll be giving our model, we'll need to extract to which features do cause humidity. We need to be able to take those features. So when we train our model can also understand based on those features. So the third action is to train the model. What basically training the model means is basically take those features that we have. There is another action here. I think I'll just define these terms and then later on I'll start explaining more on the key component of machine learning. So to train the model, what we mean, we took those features, the one we extracted or we have feature engineered. Those features will go on giving it to the model and saying if it will be labeled, it will be trained. It will be told like this is supposed to be this is healthy image, this is disease, and then it will be given different type of data. All just to train the model so it can be able to remember that if it will be given new data, that's when we go on with the last one. It will be able to make prediction or to make decision on new data, which it has not seen. So it can be able to make the decision without having that we say in programming, it's called the rigid code. Prior instruction, which was already predefined, it was already written. So basically what ML will be doing, it will be making decision, making prediction based on data that it learned. I think I'm clear up to here, so I can go on with some of the key components and the working principle to explain it for the machine learning. So going on with the key components. So key components, we already seen we need data. Anywhere you hear AI, machine learning, just know we require a lot of data to train and a lot of data to validate. So training data, this is the data used to teach the model. So if it's labeled data, then it will be telling each label, will be teaching the machine what does each label means. So when we show a new data which the model has not seen, it will be able to differentiate between label 1 and label 2. So that's the training data. If it was unlabeled data, just like the one we've seen, let me find that. Just like this one, it will be, we term it as unlabeled data. What do we teach from this data? What do we teach the machine from this data? We can teach it to find the pattern in this data. What pattern exists in this data that can be used later on to create labeled data set. From this data, there is a pattern which can be identified, or the machine can be able to pick up from this data, and then that pattern can be able to teach or can be used for creating annotation or creating label data. Go on to the second component, which is algorithm. Algorithm is basically the mathematical method used for learning. Example, we have decision tree, we have neural networks, which is artificial neural networks. So there will be a mathematical method. There will be actually a mathematical computation which will be able to tell this is it's a healthy paddy, this is the disease. So I think we remember all those mathematical which should be able to compute the distance between 2 points. And so all those mathematical, there's not just one mathematical method, there are many which are used as algorithm, which all that are the one which forming the algorithm. The model, after we already train the machine, and then we generate the model or we develop the model. So from this model, that's where we'll be giving the new unseen data for the model to make prediction. Evaluation basically will be after generating every model, after generating or developing any model, you need to validate it to be able to say my model is 90% accuracy in detecting paddy disease. The fundamental goal, the initial goal is we are trying to mimic the human behavior. We're trying to mimic the human environment. The way human works, we are trying to do that with machine learning. So after you train, you apply the algorithm, you develop the model. At the end of the day, if your machine is unable, it's unable to perform the same as human, let's say by 50%, mostly even different authors authors will say that is not enough, because you need, if you are generating a machine to be able to detect or to be able to predict the weather, it needs to be at least more than 50%. Mostly they even go to up to 80 to 90% accuracy for it to be considered you're mimicking human behavior or human environment, human way of thinking. So that the debate on current AI, has it reached the full potential of human? It can be evaluated based on this evaluation. Have we reached the actual age or the actual era whereby the machine is able to mimic 100% of what human does, especially on making decision, on checking any type of thing, predicting the weather, being able to classify disease, being able to tell this is a dog, this is a cat, this is any type of animal, to be able to classify the different type of animal by just looking at them. So this evaluation is the one telling us, if you ever do a survey after this, you'll be able to do a survey. You can see how far have we reached for machine learning to be able to classify or to be able to do as much as the human will be able to do. So this is the summarized working principle of machine learning, where we said we'll be inputting data as raw data, image data, texture data, and then from all these datas, we'll apply feature extraction. It's called sometimes feature engineering. Since the data that we'll be inputting in the model, it will be having a lot of features. Because we'll be generating model which will be able to do specific tasks. That's the one to remember here. So we'll need to extract features, attributes, or concerning columns which are seriously those columns which are affecting the occurrence of that specific thing that we want. So if we want to predict the weather, which features do affect humidity? Those are the ones which will be extracted and be given to the neural network, whereby it will be go on to predict. So if we want to differentiate or we want to detect a car, as in this picture, that means the feature that will be extracted will be the features from the car picture, which will be used in the neural network to be able to predict this is a car or not a car. If you want to be able to detect the animals, they will be given pictures of animals. Humans, we are able to detect animals by just looking at them. You see the face, you say this is a dog, this is a cat, by just seeing the pictures of image. So same way for the machine, we will be giving pictures, image of pictures, and then we'll be extracting some required features from the image so that we can be able to use those features in the neural network. So we can be able to predict that this is the cat, this is not a cat, this is a car, not a car. So this is the basic working principle of machine learning. We'll see another one for deep learning and so on. So you just need to understand this. So let's go on the types of machine learning. There are basically also, there is a debate here because there are some say 3 types, some authors say 4 types of machine learning. We'll go on covering them, and then you also, as a scholar, as you are learning, you'll be coming to write papers. From your research, you'll be able to say how many types of machine learning are there. The first one is supervised learning. We already learned labeled data and unlabeled data. So supervised learning, what it does is, the thing you have to remember out of all these words in the slide is that it's learned from labeled data. That's it. So you hear supervised learning, it learned from labeled data. And then let me go to the next one, and then I'll come for discussing the goal. And then for unsupervised learning, basically it will be learning from unlabeled data. And then we can see the goal. And then we'll have the third one, which will be reinforced learning, which is learning by trial and error using rewards and punishment. We'll see it. And then there is semi-supervised or self-supervised learning, whereby it's used the mix of both. It's used both labeled and unlabeled data. So let's go on with supervised. The basic things, the basic goal that we're trying to be able to mimic from supervised learning is to be able to predict the outcome of new data. So in supervised learning, when you say my model is supervised learning, first you'll be using labeled data, and then your goal will be toward you'll be giving the model labeled data, and then you'll be wanting to predict new unseen data by the model. So example usage, you will be trying to classify, whereby if you, for example, here it will be trying to detect spam detection, image recognition, disease detection, anything that we're trying to mimic human ways. So in classification, it can be animal detection, all that can be used in classification. And then regression will be able to predict, for example, house prices, stock forecasting, all that. We are trying to use the regression to be able to, from the data that we have, to see how can it be in the next few years, in the next few decades. So all this it can be done using the supervised learning. Algorithm which usually go with supervised learning, it's include linear regression, decision tree, support vector machine, and neural networks. So these we'll just show them here, and then we'll discuss them further as we go. And then unsupervised learning, we say this will be from unlabeled data, and then the goal is to discover structure or grouping or pattern from the data. Since it's unlabeled data, that means even human, we can understand unlabeled data. We can be able to predict which type of data is this, but you will be able to be close to impossible to be able to predict the pattern in the unstructured data or in the unlabeled data. So what basically we'll be requiring, what some examples of what what will be examples of ways of detecting the pattern in unsupervised learning. First one, it will be doing clustering. Clustering is, how do we define clustering? Clustering is being able to detect data with similar patterns, and then you put together the data which have the similar pattern. That is clustering. So we'll have customer segmentation, anomaly detection. So customer segmentation, we put customers based on their favorite ways, these favorite things of buying, or anomaly detection. From the logs of security logs, we'll be able to tell this is usually happen in the traffic, the network traffic. This is anomaly. So we don't know what the data means. We don't know if this is an attack, this is not an attack, but we can just say this is usually normal in traffic. But if the traffic come in this way, this is an anomaly. So that's just clustering. You are not able to, from this clustering, that's where you can go on further to be able to say, you can label this is anomaly, this is normal from clustering. So the supervised and unsupervised, they depend on each other. And you need to understand both to be able to further the career under AI. And then we'll be having dimensionality reduction. There is a concept called PCA for data compression. Basically, what we will be doing when you have unlabeled data, you can try to reduce the dimensionality. So at least you can be able to understand the data, you can be able to process the data. Basically, you can compress it for easy understanding and easy clustering. So some of the algorithm under unsupervised learning will include K-mean clustering, and then will be PCA, that's an algorithm, and then autoencoders. This is just for annotating the labeled data automatically. That's autoencoders. So that is supervised, unsupervised learning, and supervised learning. Then there is this called reinforcement learning. It's still new, and then we said we are learning in unsupervised in reinforced learning, basically the model or the learning is by trial and error, whereby if a model perform according to the policy, it's given a reward. This is correct. It will be given a feedback. This is correct. If it's give an error, that it will be given this is not right. It's am I audible? I think. So go on with reinforcement learning. So from this trial and error, the model will be using the reward and punishment also as data toward enhancing the policy that was given to maximize long-term reward. Basically, you're doing a trial and error in machine learning. After trial and error, when the machine learning gives you a correct mimic or a correct response, you're giving it a reward. That reward is also a data added to the model to be able to be used later for long-term reward maximization. And then the punishment will be used to reduce that error so that the machine has learned not to bring up the error again. So some of the algorithm and reinforcement learning include Q-learning, deep Q network, and then police gradient method. But the thing you need to remember is in reinforcement learning, the reward and punishment is also used as data to maximize the long-term reward. Basically, the goal is to maximize the long-term reward. So the long-term reward, you'll be able to maximize it by having the reward and punishment data so that the machine can be learning from these two. Semi-supervised and self-supervised learning. This is the type of machine learning whereby it's used both labeled and unlabeled data. It's most common in NLP and computer vision. Someone will come and cover this much more, but it's basically those two type of labeled and unlabeled data. They are given to the model, and then the model will be able to learn from it, both labeled and unlabeled. It will be, if it's unlabeled, it will be able to complete it, and it will be able to balance out any biases, and then try to from there, it will be given new or unseen data. It will be able trying to predict. It will be able to do vast tasks apart from only able to classify, do regression, or do clustering, as we have seen in the supervised and unsupervised. So these are the 4 types of machine learning, but some other papers only discuss 3, some other books only discuss 3 types of machine of type of learning. So summarizing the machine learning, we have supervised learning and supervised learning, and then we have reinforcement. We have 4, and then these are the algorithm. So I'll just skip since we already discussed some of it. But in unsupervised, there will be DB-scan and then a priori or association models. In neuro or supervised, we'll be having CNN, RNN, and then transformers and all that. So in reinforcement, we already seen the algorithm which fall under reinforcement in types of machine learning. So there is a concept called inferencing. This is just a term. I just wanted to introduce it because we already seen we can train the model and then we can validate the model. After validating, this inferencing is just a term whereby it refers to a trained model. After we already train the model, we'll be making decision on new or unseen data. It just means that. So on inferencing, we'll be doing 2 types of inferencing. We'll be having batch inferencing, whereby after you trained the model, you'll be testing or you'll be inferencing on a lot of data in one time. It analyzes a lot of data and then give a result on all in batch it will be giving also a batch result of all the data that was given for inferencing. And then real-time inferencing, that's, we can say, real-time detection. You already trained the model, and then from that model, let's assume it's a paddy disease detection. From this real-time inferencing, that means if you give new unseen data unseen data that the model has not seen that model, the model has not seen the data, it will be able to tell this, either this is a disease, or if it's classifying animals, it will be able to tell this is a dog, this is not a dog. Whether it's in car driving, it will be able to tell now increase speed, now decrease speed, based on the environment, based on the new data that the model was given. So that's inferencing. We'll finish ML by discussing the challenges in machine learning. Since we already started, we said we are trying to mimic the human. By mimicking human, we need data. So the first challenge in machine learning is data quality. I put it in a negative way, garbage in, garbage out. So if you train your model based on noisy data, it will not be able to detect clean data. It will be able to detect data which are similar to the data you use to train. So if you train the data using biased data, that means you will also be getting biased results. So that's the first challenge. That is the most common, because in order to be able to develop a good machine learning, you need the data which has good quality. From the initial start, when we were studying learning machine learning, we were just discussing data, and then we were saying we need data in our machine learning. But if we start with advanced machine learning someday in the future, we will be requiring to ensure the data quality. The data need to be good for your machine learning to be good. And then the second challenge is overfitting. Overfitting is when you have the training data is way too much. The training data, there is this very small difference between training data and the data you use for validation. That's when overfitting will be coming. That you're training your model using data, and then the new data that you are introducing to the model is it's almost similar to the data you use for training. When I say similar, I use it in a sense like it's the same data. That's when the model will be creating something called overfitting. It will be performing perfect well on the data that was used in training, and then you use again for validating. But if you train it on the field data, that's the model will be performing, the model accuracy will be dropping dramatically. So let's assume you create a model whereby that model, let's assume, is detecting and it's detecting animals. This is the dog, this is the cat. You train the model, and then you validate it. You get an accuracy, let's say 99.99%. So based on your research, your model perform based on your research, your model perform very good. But when we go and give the same model the data that it has not seen, the performance dropped from 99.99, it dropped to less than 50%. That means your model had overfitting challenge because it was having memorizing issue. It's learned on the data in a sense that if it's given new data, it failed to detect completely. But if it was given the data that was used in training and validation, it shows good accuracy up to 99.9. So this is also area of research whereby if you're training your model, you need to be able to use real-time field images or field data that is new to the model. So you can see if your model is performing real well or it's having this overfitting challenge. And then we have computation costs. As usual, the training the machine or training the machine to be able to mimic the human comes with a lot of computational cost, including for both GPU and TPUs. These are all expensive, whereby these are chips which are required to be able to train and then validate the machine learning. But the one which will be doing it won't be as much as computational cost. But if you want to generate a machine learning that can do a lot of tasks, that can do different type of tasks, same as a human, that means you will also require a huge computation so that you can be able to train and then you can be able to do anything or to validate the model. And then we have ethics and bias. This just more, it's not more technical, it's just the model can amplify society bias. For example, hiring algorithm may say, may favor certain demographic based on what the data used to train was used. So, for example, if in the data quality, with this a little bit intertwined with the data quality, if the data you use had bias, so eventually another challenge will be coming. It will be ethics and bias, because you won't be giving the right response to the people or to the data which do not adhere to your data which you used in training your model. For example, let's assume we generated the model in this ethics and bias. An actual explanation can be, for example, if we create a machine learning to be able to detect facial expression of a human, or to be able to just tell, is this human smiling or is this human laughing, all that. So if you train your data on pictures of human, whereby all the pictures, they are not smiling. And then later on, you came to do inferencing, you give the same model a picture of someone smiling. Eventually, the model will say this person is not smiling, because the data which was used was of the people, of humans whom were not smiling. So that's the bias. So that came to ethics and bias. And then explainability. This is, we'll see mostly in machine learning and deep learning. This explainability is actually most of the, it's an open area for research, because many machine learning, especially here we talk about deep learning, whereby we are saying they're black boxes. For machine learning, there is usually a question here that say why this model we put it as as explainability challenge. First, let's assume we have a model just same way as a model which will be able to detect facial, or it will be able to detect animals. It will be able to detect cat, difference between a cat and a dog. This model will be having an accuracy, let's say 99.9. That means there is a 0 point something % whereby the model will be given a picture of a cat, and then it will say that's not a cat. Remember, we trained this model by saying, let's assume we use labeled data. This is the cat, and the model say 99.9 of the times it's confirmed. If we give it a picture of a cat, it's confirmed that's a cat. But there is some chance whereby it will be given a picture of a cat, and then it will say that's not a cat. Then how can you explain that? So there is a little bit of more research required, so we can be able to explicitly explain what this new data has that the model doesn't have. Because as human, if you see a cat and you say it's not a cat, you'll be asked why this is not a cat. You'll be able to explain it a little bit. You'll be able to say the ears, the furs is not there. You'll be able to explain why you're saying that's not a cat. Well, for machine learning and deep learning, that's not the case. It will be able to predict to even 100%, but there will be some point whereby it won't be able to tell exact. It will be giving you false positive. This is not it, while it's supposed to be a cat. So from there, the explainability, like why this way, not that way, it's not there. It can be giving you an accuracy with a confidence level. So it can be saying this is a cat, and the model is confident with, let's say, 99% confident this is a cat. But it's not able to explain why this is a cat. So that's an area of research too. So from there, those are challenges in machine learning. I just finished. So any question on these challenges, and then you have like 30 minutes or 27 minutes. So I can start with fundamental of deep learning. Are we together? Okay, let's go on with the fundamental of deep learning. From AI, machine learning, now we are into deep learning. Still, the goal is trying to mimic the human. With deep learning, we are trying to mimic human brain structure using layered neural network that process data hierarchically. So basically, we'll be having neural networks, whereby from these neural networks, they'll be used to learn data, and then it will be used to able to predict new data, just like the neural network of human brain works. So it will be having layers, whereby basically we can, it has 3 layers, where the first one is called input layer, and then the second is called hidden layer, and then the third is output layer. So you can see both for machine learning and deep learning, there is data required as an input layer. It will be receiving raw data. And then for this data will be including pixels of an image, word in a sentence, all that data, as we discussed, structured and unstructured, will be given. And then from there, will be having hidden layers. These are multiple layers of neuron that will be extracting increasing abstract feature. In machine learning, after input layer, we were going for feature extraction. We were going for the features that we want to extract so that we can teach our machines. In deep learning, we'll be having consecutive neural networks, whereby these neural networks, their task is to extract increasing abstract feature. It will be first doing extracting from the data that we have given, it will be extracting some, and then it will be increasing abstract feature. It will be taking the parts of the image or parts of data that are relevant, and then it will be increasing it. We'll see some of the functions which are done in DL, which will be increasing the abstract feature. When we say abstract feature, that means if you are trying to detect an animal, each animal has features. So basically in deep learning, there will be an increasing abstract features of those features which were extracted. We'll discuss it much further later. And then we'll be having an outputs layer, whereby this will be the one which will be showing the prediction. And then it will be able to basically classification and regression and all the other prediction that we can be needing to mimic the human. So the key concepts, we say there are neurons or nodes. So these are basic computation units, which will be applying weights and activating function. Now we can, okay, let me discuss weight and bias. There'll be a term called weight and bias, and then will be activation function. So already up on top, and then there'll be something called back propagation, pooling layer, convolution. Okay, let me go back to this hidden layer. So inside hidden layer, there will be this neuron, more than one. So from this neuron, we said in the hidden layer, we'll be increasing abstract features. So basically, we will be having weights based on these features that we extracted. How much weight do they have so that they can be passed to the next neuron? They can be passed to the next layer, next hidden layer. So basically, they'll be having activation function. These activation functions, basically, they introduce non-linearity. Because if we don't introduce non-linearity, what we'll be doing, it will be basically, I think it will be linear regression if we don't introduce non-linearity. So that's why in deep learning, we want to introduce this non-linearity so that we can be able to get this increasing abstract picture. So if it's a curve, we can be able to get it as a curve. That's why we'll be having this activation function, as these are ReLU, sigmoid, softmax. These are all activating functions which are introducing non-linearity to the deep learning. And then weight and biases, these are parameters which are adjusted during training to minimize errors. So for example, let's say weights and biases. For example, you have features to be able to detect a cat. One of the features to be able to detect the cat is the ears of the cat, the face, the eyes, the fur. So based on these features, we can introduce weights and biases so that we can be able to tell, in order to identify or to differentiate, to classify a cat from a dog. Both have ears, which almost look similar. Both have fur. So which weight or which biases should we able to introduce to the model so that the model can be able to tell the cat and the dog look similar. But based on these weight and biases, this is the cat, this is the dog. Hope I'm trying to put it well. And then we have something called backpropagation, whereby the model or the algorithm optimize weight, use gradient and descent. We have several layers. From these layers, there'll be a point whereby there'll be a concept of backpropagation, that the data which was fed to the layers which is in the front will be given to the previous data so that it can be given to the next layer again, so that it can optimize the weight and be able to classify or being able to detect the anything that we are trying to classify or to being able to detect. There is another thing called pooling layers. From a machine learning perspective, we were having feature extraction, whereby that feature extraction, we were reducing from the image, we were taking only some of the features. So with pooling layers, since in the deep learning, we'll be taking the pictures up to the pixel fit. So we'll need to reduce the data. We'll need to downsize the sample to reduce the spatial size of input. Remember, the picture or data that is given to the deep learning, not all of it will be used to be able to detect, to be able to classify the image that was the data that was given. It's only the important part of the image. So pooling layer, they are optional, especially when it's come to deep learning. But if you're having data which is more spatial, when we say spatial, that means your data is across several. It's spatial. It's like separated. If it's in a table, it's separated in the entire table. So we'll be using pooling layer to be able to. It's like finding the average of the data of the feature data that will be used to the training and in the hidden layers. So pooling layer, that's the concept I can introduce as simple as that. And then we'll be having convolution layers, whereby these are the deep learning, these are the columns are the neurons. I'm using different terms. Here I use hidden layers, then here I use convolution layers. I use convolution because I think it's, but since we're doing deep learning, it's supposed to be just hidden layers. So basically with convolution layers, these are the ones which are trying to detect each features from the data that was given. So we can have several layers. We have models which have to 121 layers, even more than that. So basically what this hidden layer, what they does is they try to detect one features for each layer. So one layer can be able to just to detect the edges. So if the model is given a cat image, it will be just trying to detect which are edges that the cat had. It will be taking those edges and then it will be learning from them. And then we can go on pattern. It's which pattern that this picture has. We can go for textures. We can go for colors. So these hidden layers, they will be extracting those specific features based on that specific layer. And then all these features will be connected with dense layer, which is called full connected layer, where it connects each hidden layer, whereby written convolution, it will be connected to this dense layer from one layer to every neuron in the next layer, so that all those data or all those features which were collected, they can be placed in the full connected layer, so that next time when you give it an image or a data, a new unseen data, it will be able to, it will extract. Once it reach convolution layer, it will extract, or once it reach hidden layer, it will extract all the features, edges, textures, and pattern. And then it will compare with the one which are present in the dense layer to be able to tell this, to be able to tell this pattern resemble a cat, this pattern resemble a dog. So let me summarize the deep learning, because there are many types of deep learning. We'll go on, I'll fast forward to these types of deep learning, but let me discuss everything I said about deep learning using CNN, which is convolution neural networks. So from the left, we'll have an input. It's a picture for our example. And then we'll have this convolution layer or deep layers. From these layers, what they'll be doing, they'll be extracting features from the image. So it will be taking edges, textures, patterns from the image. And then if we need to apply the pooling layer, we said pooling layer will be reducing spatial dimensionality, spatial data. So from all the data that we collected, we are trying to reduce to the one which will be needing, so that we can be able to make a correct prediction. And then from all these data which are in convolution layers, all these data which were extracted in convolution layers, which each layer, it will be connected to the full connected layers. So next time when you come to give it a new image, new unseen image to train, what will happen is that in full connected layer, it will be having all the features which we have previous trained with. And then this output node is basically each feature will be in one array, whereby we're putting it in one array or in one output node, whereby it can be given to an activation function, which is softmax, so that it can be able to learn from all the pattern that it learned from the new image, to be able to make a prediction like, based on the picture given, this is, I'm confident by 89% this is a dog, or I'm confident by 0.03 this is a cat. I'm confident by 0.08 this is the 1.3 was a cat. This 0.08 is a cat. So from all this, it will be able to make prediction. So you see, deep learning, same as machine learning, it learns from the data. From the data that it learned, it will be able to make new decision mimicking the human, but it will be having the limitation that it won't be able to always being able to tell this is a dog, this is a cat, and so forth. So Any question on the deep learning foundation introduction, which I give? Any question? So one of the question I need you to ask yourself and understand up to now, which you need to be able to understand, is to be able to tell the difference between machine learning and deep learning. You need to be able to differentiate the two. If you are given a model, can you be able to tell this is the machine learning, this is the deep learning? And apart from that, you need to be able to tell what the difference between machine learning, deep learning with a programming language such as Java or Python. And then we'll be using Python to generate some of the machine learning and a little bit of deep learning later on. But what will be their difference between the model and the programming language? So this later on, I'll start discussing the different types of deep learning. Different types of deep learning, there are many, and each has their different way, different usage. So there is FNN, feed forward neural networks. These simple types of ANN, whereby data flow in one direction. You flow from one neuron to the next, and then it will be going on forward only, whereby from those data you'll be able to get prediction from the previous neural networks. I'll just explain it in short because we're only discussing the type. But if we need to go to the feed-forward network, it's also a little bit. It has its in deep detail on it itself. So the next one will be the convolution neural network (CNNs). This is the most common. It's most common in detecting image, videos. In videos, we mean video frames. So it's mostly used in detecting edges, shapes, objects from the images. So this is the most common one, and that's why I use this to explain the entire deep learning, how it works. The application include image classification, that being able to tell from the image, this is the dog, from the image, this is the car, and all that, and then be able to detect objects from the image. If the image can have small objects or objects in it, it will be able to detect using this. You only look once, faster RNNs, medical imaging. So CNN can be used to detect if you give it an image from a medical, the CT scan and that, it will be able to detect any type of disease from the image, but it need to be pre-trained. The other type of deal is recurrent neural network, RNN, and short-term memory neural network designed for sequential data, where we talked about time series data like weather data, the data which has continuously coming. The only difference will be the time. Text, speech, that is, we can use the RNN to be able to train and trying to be able to respond to the human, mimicking the human. So I'll just skip this one. And then we have transformers, which are self-attention models. These are the one which are revolutionizing NLP, natural language processing, by replacing RNN with attention mechanism. This attention mechanism will be covering it later on. I have like 9 minutes. And then the key models here will be having BERT, and then GPT, generative pre-trained transformer. BERT will be directional encoder representative, and then we'll be having vision transformers. They will be able to, from CNN, we are seeing it's used in being able to detect image or object from image. But vision transformers, these are also used to detect image, but much more recent. This is a different way of detecting images. Let's go direct to the challenges. Just as for machine learning, but for deep learning itself is a data hunger. It requires way more massive data set in order to learn. If you're giving deep learning data which is limited, it will be not learning enough to be able to give you a good prediction or good classification once you give it new data. The second thing is having high computation costs, need more GPU and then TPUs, which are both expensive, same to machine learning. And then the same problem of overfitting, whereby if you train the data and then you validate the model on the very, very similar data, it won't be learning. It will be what will be happening will be overfitting. So if you give a completely new data, the model won't be able to learn as much. And then we talked about black box problem, whereby it's hard to interpret the decision, especially when it comes in healthcare or law. We talked about that problem of the model can be 99% accurate. So if it's 99% accurate, and then we are talking about healthcare or health in general, it becomes a problem because you need to be at least way more sure than that to be able to tell someone has cancer. If you have tell someone has cancer from machine, you put his images into a machine and then the machine says like, this person has cancer. You need to be very, very sure like he has cancer by having a human cross-check the machine data. Because if you tell someone he has cancer and then he doesn't have cancer, it has problems. Again, in law, it can have problems when laws require at least 100% sure, 100% accuracy. So since our machine learning, it's not 100% accuracy, it can be having these issues. And then the ethical risks with deep learning, the ethical risks are much more, just like we can be having deep fake, bias AI, and job displacement. Ethical risk, we are talking about job displacement, but basically it will be happening to someone who is not incorporating themselves with these new technology, new machine learning that's coming. But if you are able to do your job and then you are able to apply AI doing your job, that means you'll be way more productive than someone who is not using this machine learning, deep learning in their job. And then deepfakes, they are the one generating contents or which are looking just like real, but they are fake. They are being machine generated. So that can have an ethical issue. So for example, the machine can learn from your picture and then generate a picture similar to yours. And then from that picture, which is similar to yours, it can be misused somewhere in the internet. So we need also new laws because I think the ethical people and the law will be able to explain it much further. Like if we generated a picture similar to yours and then we misused it in the internet, if you go to court of law and then you open a proceeding, how are you able to go on with the proceeding if that picture was not really belonging to you? It was just a picture generated from the looking or the feature from you. So it has we need new laws which need to go with the advancement of this machine learning and deep learning. So I'm done with deep learning. Any question before we go to generative AI? Just a bit, which is also part of deep learning, and then we finish the session. 4 minutes, so let me go on. Generative models. These are the model whereby they can generate new data based on the data that they were given. So, we talked in the deep learning, in the type of deep learning. Generative AI can be able to generate new data which look or even 99% similar to the data that it was given, but it's not necessarily a copy and paste. So that's the generative models or generative AI. So the types, it include generative adversarial network, variational autoencoders, and diffusion models. and then I've included also the models which do this type of generative AI. So the model always will be given data. From the data which it will be given, it will be able to generate the new data. Okay, generative AI. Okay. I think I already talked about this. It's generate new data from existing data, mimic human-like creativity. For example, how do we say human-like creativity? We human, once we see things, we see pictures, we see movies, we see anything, we'll be able to generate arts which will be based on what we have seen. We'll be able to draw something based on what we have seen. For example, if you are a human and then you are asked to draw a human or to draw a bed, you will eventually include some of the features which will be including a head, two eyes, a nose with two nostrils, a mouth, teeth. Those are uh, what we've seen. And then once we are asked to draw a human, we will be doing something closely which has features like a human. So same way for generative AI, once it's given enough data, it will be able to generate new data based on the data which was given. For example, there's been a discussion, I think it's about ChatGPT. I think during training, the most of the data which were used to train was a human or a person writing used a right hand. A person writing used a right hand. So if you went to the same model and then prompt it to give you a picture of a person using a left hand, it will eventually generate a picture of a person using a right hand. That happened because the data which was used to train, a lot of it was of a person using a right hand. So these kind of things we generate, but the bias we talked about or the weight we talked about, it will be coming based on the data that was already aligned. So what basically generative AI, it will be enhancing or modifying existing content. It will be able to modify or it will be able to regenerate it in a different manner. It will be able to generate it in a manner that data is not from it, but is based from the data which was given to it. Or it can combine 1,000 images to be able to form a new image. It can combine several paragraphs to be able to form a new paragraph. So generative AI include ChatGPT and Stable Diffusion. These use that last type of that type of learning where we call self-supervised learning, whereby it includes both labeled and unlabeled data. And then if it has missing parts of data, it will be predicting it. Also in machine learning, we'll be able to feed missing data, how to handle missing data. But for self-supervised learning, it will be predicting just the missing data. And then any question in general, I think I'm done for this session. Any question up to now?
Thank you, Freddie. Thank you once again. So yeah, here is an announcement for all of you. The second session of day one, that is today, will begin from 12 noon. So please start joining by 11:55. Now you can leave the meeting and go for break. Thank you.